Thanks everyone for coming to the Utah Microservices meetup tonight. Nadine just stepped out. We will save that for later. Big thank you to our host, LiveView Technologies, for providing the space and the pizza. Big thanks to Omni for providing the Zoom link. Let us go around the room and do introductions. And once we've finished in the room, we will go to online. We'll skip me. Brian, would you like to start? And then we can go that way.
Sure. Hi, I'm Brian Sorge. I work for LiveView Technologies as a software developer, and right now we do most of our work in Eventide. So it's fun to come to meetups and see what's going on and see what other people are doing. So
right on.
Yeah, I'm Casey Allred, work for WSGR, Wilson Sonsini, whatever you want to call it. And yeah, we use a lot of Eventide and Ruby and so.
Whizger.
Yeah, Whizger,
if we want to call it.
Okay. Don't ask me to spell all the names.
Troy Thomas, I'm a software developer with LBT. Been doing some Eventide stuff for a while now, about a year, and work in the cloud space.
Hi, this is Swapna. I work for LBT as a software engineer, and I do with the Eventide stuff. I'm active, but yeah, I touch with the Eventide stuff. Wishing to work more.
Alex Oliver. I work for Unique as a software developer. I'm Steve Noel. I've been at LBT for a grand total of about 4 weeks now, doing Eventide. And
I'm Dan. I work at Omni with Ethan. I'm actually not like one of you. I'm a cloud security engineer, so I'm here to learn a little.
Nadeem is here, Executive Director at LBT, and glad to have you guys here at our new campus. Welcome.
We're going to come back to you once we finish with the introduction. So anything you want to say about LBT, Jan? We'll go to online in the order that folks are on my screen here. Scott, you want to introduce yourself?
Sure. This is Scott Belware. I'm the creator of Eventide and MessageDB. And along with Nathan Ladd, remain owners and managers of it and core contributors. And I'm also a co-founder with Nathan of Brightworks Digital, where we make our consulting home and our consulting business. And as you might imagine, a lot of our work is Eventide and MessageDB work and autonomous components and services, but also we do a good deal of our work in design, testing, process management, and all things software product development. Thank you.
Thanks, Scott. And Antoine.
Hi, everybody. I'm a software developer. I'm based out of Austin, Texas, and I am a user of Eventide. I've been working on the project that Casey is on with Eventide for about a little over 2 years now. And I'm also working with Brightworks. So I know Scott and also know Ethan. Nice to meet you all.
From your accent, we could tell you were based out of Austin.
I know, right? Typical Texan accent.
I tried to cover my accent, but I did not do a good job. It's just Texas, and I don't want to make everybody in Utah feel, insecure because they're not French.
Sam.
Hi. Hi everyone. From my accent, you'll probably think I'm in. From my accent, you'll probably think I'm in England, but I'm actually calling in from Bolivia, so it's a little bit further afield. I'm a software engineer for a company called Hubadoo. We've been using Eventide for 2 or 3 years now, probably, I would guess. Lots of Eventide, lots of Ruby. Slowly moving towards getting our existing systems rewritten on event-based stuff and the advantages that will bring. And yeah, hi everyone.
Can I ask you what city in Bolivia?
Yeah, I'm in Tarija. It's in the south near the border of Argentina. It's not very big, but it's in the wine growing region.
Yeah, okay, very cool.
Thank you.
Why did you-
Yeah, I've been in Bolivia for a couple of years, so I just wanted to know.
Oh, oh yeah, my wife's Bolivian, so I'm living here for the time being. So strange
Fantastic.
coincidences.
Yeah, served mostly in La Paz, so.
Yeah, yeah, no, La Paz. I prefer it. I prefer it down here in the south. It's a lot greener,
Oh, I know.
a lot warmer.
Awesome. Cool. I think that's everybody. So Nadine, anything from LVT you'd like to say?
No, welcome. And we are very happy to host these meetings every month. And thank you for coming. And we are learning a lot. And I think majority of you I have met in a couple of different meetings. We are heavily investing in microservices, Eventide, and Ruby. We have lots of positions open. Check out our website, lvt.com, and apply. Thank you.
Right on. Thanks, Nadine. Okay, so I don't even remember the title I gave to the presentation tonight. Let's see. Using telemetry to improve testing. Telemetry was capitalized there because there is an Eventide library called Telemetry. And you would use it not expressly for the purpose of testing, but if you're using it, you get a lot of power in your testing. And so the real goal of tonight is when we're writing message handlers, we have, I can just pull up an example. Oh, you know what's really smart? I haven't joined the call from the computer I'm going to present on. Can anyone hum some hold music for about 10 seconds?
Joy, make sure you authenticate yourself as being.
Yeah, somebody, you think Arful is trying to get in?
Antoine, French national anthem.
Allons-en.
The only part I know the part that goes, oh wait, this is being recorded, right? Ah, crap.
Yeah.
And I will be sure to extract shorts to put on YouTube. Jerry just joined us. Jerry, do you want to say hello and introduce yourself real quick? We're still at the very beginning here.
Okay. Yes, I work at LVT and I've just been programming and I've been doing Eventide stuff there and lots of other things. So
Welcome. Okay. My screen.
Ethan, I'm sorry for jumping from machine to machine and making you go back and let me into the room, but I keep losing connections, so I'm sorry. I'm going to jump to another machine.
No worries. We'll see it.
Read a minute or something.
For now, yes. At some point, I will need this as my cheat sheet. Okay. Let me pull up the Eventide examples. I don't know if anyone here has seen the account component example before.
That's new.
Anyway, so in the handlers, we typically have this dependency on messaging Postgres write, which is the class that gives us write access to MessageDB. It's one of two that gives us that access, but this one deals with messages. And so when we're doing tests, when we're testing a handler, we end up using that in those tests. Just getting a random test here. We instantiate a handler. Later on in the test, we get a reference to that write dependency. And then there are several messages that you typically call on it. The goal of tonight is to understand how this writer substitute came to be and what these messages mean and how those methods are able to do anything useful for us. And that's going to take us down a journey of the telemetry library, I say library, I think we all know enough Ruby, I could say gem instead of library, same thing. Using the telemetry gem and the dependency gem and some conventions around that. That's the goal. I will say I have not done a practice run through of this, so bear with me. That the ask that I would have is I don't have as many visuals as I would like to have for what we're attempting here tonight. So I don't want to move past anyone's level of understanding. So if at any point you have a question, please raise it so we can make sure that we're all understanding things as we go along, okay? All right, so this is where I now need this and to look at my code here. So what we have is a repository, and I could actually post that up here into the chat if anyone wants to look at it. That is from, that one might look familiar to you, Kyle. Thursday of last week. Let's see, this one. I don't endorse mono repos. This one happens to be a mono repo. That was in the interest of time. Where is the chat? There it is. So if you want to do that, I should probably post that on the meetup link as well. Sorry, this is whatever. I'll do it later. It's in the chat. What this repo has in it, there is a component called thing component, which is there just so we can have the mechanics of a component to show something. We have this text folder and the storage folder. And the basic structure of those two is ripped off, inspired by the messaging and messaging Postgres gems. So text, messaging, storage, messaging, Postgres, just think that. And there is in here a write module that serves the same role as messaging write. And then this file folder contains the messaging Postgres functionality. Like it's kind of whack how it's laid out. And then storage here contains the equivalent of messaging Postgres put. I don't know if any of that's useful. Hopefully these will come through as we're going along. So where we want to start is just a real quick overview of telemetry, what it is. At some point in the future, someone's going to give a deeper dive into the telemetry library. Tonight's is not meant to be a deep dive into telemetry. We'll look at it just enough to serve our purposes for tonight. And Scott, I hope I don't butcher the purpose of this library, but you have objects that are first and foremost behaviors, and they do stuff. And who here has used mocks before as you've been writing software? Yeah, let's see those hands, like you probably have. You had to use mocks because your code wasn't observable enough. It was opaque what it was doing, and so you used mocks to put something that was observable in place of the thing that is not. Telemetry, this library, the concepts behind it would allow you to be able to test things without having to rely on mocks, basically. What telemetry does is you're able to instrument your code to record signals of stuff that is happening. This example here, this class something, I don't want to use that one because I think it's a little abstract to get the idea across. So let me, let's see, that's telemetry, mimic, message DB. Oh, that's message DB, right? That's not going to help either. Let me get Eventide messaging. This is the one that the text folder in the code we're going through tonight mimics. But like if you come down to right here, when you write a message within your handler, you're probably using the code in this file, unless you're doing lower level stuff, which is rare. But this call method is what you're actually calling when you see write dot whatever in your handlers. And you can see down here after it's written. So this is the line where it goes and writes the stuff. That calls a collaborator that this module references. But right down here, you'll notice it's calling telemetry for each message that was written. And it's recording a signal written, and then this data, you can shape it however you want to shape it. This is data associated with the written signal. That makes sense so far? So within the normal operation of any class that includes this module, I don't know how much Ruby you've done, Kyle, but the main way to reuse code in Ruby is through what are called mixins. That's contained in a module. You'll see the syntax for how that happens. So you can think of it as like, here's a class definition, let's bolt into it this module. And so now when you make instances of this class, you get to reuse the code from the module versus using inheritance to do that, which inheritance isn't meant for reuse, it's meant for substitutability. The modules give you a good way to reuse code without the pain points that trying to use inheritance for that purpose would give you. So it's a code reuse mechanism. Anyway, so as the normal course of the operation, this class deliberately records that certain signals have occurred. And then you can then hook up an observer to those signals without having to mock the class that's providing these signals. So it's just like, you don't need to do weird things in test to see what's going on if you build your classes to instrument what they're doing. Any questions so far? Okay. Worth calling out if you ever dig through this file on your own or as we go through it tonight. This telemetry right here is not referring to the telemetry gem. There is a submodule within Write called telemetry. And so it's referring to this data structure. But all right, I'm going to jump into code now because our thing is that we are going to end up, let me show you what we're headed towards by pulling up. Is the text big enough for everybody? I can increase the size. Here. Troy, in case you good.
I'll just look that way, I can see it.
It's a little small on my end.
Okay, let me bump it up a couple. Is that good?
Mm-hmm.
Okay. All right, cool. So into this silly thing component here, I have a handler and I declared a dependency write, but instead of being messaging Postgres write, it's this thing called text file write. So it's a text writer as opposed to a messaging writer. And it's a file storage specialization of that. You could imagine you could write text to a socket or posting it to some website or whatever. That's our dependency. And this handler violates so many principles of good handler development. Like there's no idempotence check or anything. It was purely just to get something to exercise it. So if you leave here tonight and take from this that your handlers can be 2 lines long, I'm telling you now, you missed the point. So, don't do that. This is purely just to get something to use it. So we need to write all the code that makes this work. And what we will do along the way is see how to use telemetry to instrument what our code is doing, and then how to leverage that to provide a substitute to let us to ask questions about what the class did in our test scenario. Okay. Pausing. Hey, Justin. Sorry, missed introductions.
Forgot that it was 6:30.
Oh, well, welcome, welcome. Okay, so to do that, so we go into the text deposit, not text folder here, and we will open the write file, not the correct file. It is also the correct file, but I didn't mean that version of write. Sorry, that's the level of humor you can expect from me. And we're gonna go into this test file first, and then I'm going to cheat and pull up the completed version of this file here. And the purpose of this test is we want to make sure that we are connecting the activity that goes on to the telemetry object that we are going to have within our class. We don't have any of that yet. We're going to develop it. And with a loose test-driven development flow, we may not go that far. So we would need an example of something to write. We're just writing strings of things. Texty, that's awesome. So let's see here. I'm going to go up to where this control is defined. And that is in text controls, right? For those not familiar with controls, it is something I can't describe while my mind is focused on something else real quick. But so if anyone else wants to take a shot at that while I pull up a file, go for it.
I don't want to steal your thunder, you know, right?
No thunder to steal, my man. Here we go. And text. Okay, so when you're writing a test, you need data, right? Sorry, the way I'm explaining there, it's going to sound like that controls exist for testing. They don't exist for testing. They exist because they're useful. They happen to also be very useful in testing. When you make some software program, whatever, you're going to have data in it involved, or data involved with it in various constructs. This controls methodology is saying that as the developer of something, it is my responsibility to provide examples of what the things I'm building look like. It is not the job of a tester testing my thing, even if that's me writing the tests, to come up with those. And there's a really solid foundational reason for that. We say that things that change together stay together, right? So if two things change with one, if this one changes and this one changes, and that's always in lockstep, then those two belong in the same place roughly. So what would cause examples of our data to change? Changes to the code. So when I make changes to the code, I should also be making changes to the data at the same time. And so that would suggest that the example data and the code being written, those are the same. They're coupled together. They belong together, not necessarily in the same file, but we don't relegate that to a thing of testing. Someone using our code should never have to come up with an example of our data.
We put them in the component folder and not in the test folder. And someone's asked about that recently. Why is that the reason? Is because you want them so close together that you even include them,
yeah,
the controls folder in the component rather than in the automated tests.
Were you gonna add to that?
Well, I was just gonna say the concept of controls is kind of like, you think more like a scientific experiment, right? Like you need to control some part of the system that you're developing in order to verify that, you know, your experiment worked, or, you know, so I want to control this part. I put this other thing into the system and I observe that what happened is correct, right? So that means it is like a part of the system you're developing. It's an important aspect, right? And testing itself doesn't limit it to just, you know, automated testing or like running from a console testing, right? You can have controls and things that like endpoints to influence the system that someone could be using from their web browser or whatever, right? And so, you know, you have controls that are at the level that you're observing. So you could influence something from your web browser and then observe from your web browser that the system did what you expected. Things like that. There's a lot more into that. We don't need to. This isn't what that meetup's for. But I just want to point out that it's not just limited to data or whatever. It is an important part of the system you're developing, is to be able to control it.
So in science, the control in an experiment is the normal one, the one you don't do anything to, the one you don't manipulate. So you can observe it at the beginning and at the end.
Right. And it's what allows you to verify that your experiment, the observations are good, right?
So we've used controls before. We've built controls that have things that they should in a normal circumstance. And we've also built controls that contain states that shouldn't exist, that the system should reject. Would it be better to just build controls that are the things that should be, and then in the tests, modify those things that should be to broken states that the system should reject? Or is it okay to have controls of both kinds?
There are like scenarios where you want to verify if something happens, like you control that this is the state that the system will be in. I want to verify that like the observed effect is that it behaves in such a way. So then that makes sense. That's reasonable.
Okay.
Right?
All kinds are controls.
Yeah, it's like I need to control this aspect of the system. Like I got faulty data, therefore I need to make sure that this observation happens, right?
Thanks.
If you've used web frameworks before, like especially in Rails, there's the notion of fixtures. Those are a thing of test and quickly become a mess to work with. And I think part of that becoming a mess because it's a thing of test and not connected through the code under development as it ought to be. So this control, we're saying this right thing that we're developing writes.
Can I add something to that, Ethan?
Very well, yes. I don't know.
Just to the point of why this stuff is, you know, in the package itself, and the simple answer to that, and it's probably so self-evident, it might be even annoying to say it. The reason that these controls are in the package itself is because if they weren't, we could not ship the controls with the package. So where would the controls be if we put them in the test directory? They would never be packaged with the gem. And therefore, an adopter of that package would never have the benefit of the work that the implementer invested in providing a set of controls, or think of it from that perspective, exemplars that demonstrate exactly what an average canonical representative instance of some object is, or a typical way to cause some side effect in the system. So these are things that we give. These are benefits that we hold ourselves responsible to giving to other people, as well as ourselves, when we build a library, so that they have at their disposal a means to quickly access exemplars that can in turn be considered scientific controls, especially since that the person or the people who built the package to begin with are in the best position to know what a representative example of an instance is.
Think of all the times you've used an open source library and you wanted to experiment with it. And you're like, oh, wait, what do the parameters I pass to this thing look like? So you've got to go hunting through documentation, maybe into the source code. What if the library just gave you a representative example of what you were working with was?
Yeah, and from a testing perspective, like there's a really important point that I think all developers have to come to along the journey, which is, and Ethan pointed out things like fixtures, and there's things like factory bot and all of those things. Those are things that, and even mock objects, those are things that are developer centric, and it's a developer centric viewpoint on what software testing might be. If I'd learned about software, if anybody learns software testing from developers, and if you spend your life with developers, that's the entire universe. Like that's like a fish in water. I don't really know that there's air out there. But once outside of that world, you can see how small the perspective is on testing within the software development world. So factories, fixtures, mock objects, that's quote unquote 2 words: developer testing, not testing, developer testing. The bigger, broader world of testing has accommodations for a lot more ideas, a lot more powerful ideas. Not to say that fixtures and mocks and all that stuff aren't effective; they are, but they're quite a bit more limited in their perspective, and we can cover a lot more ground by adopting the things from the general larger world of software testing than adopting just the stuff in the developer testing world. However, it's inevitable because we're developers. We're always going to learn the developer stuff first. The challenge is to learn that and then go on beyond it.
Thank you.
Thank you.
Thanks, Scott and Casey. And it was a good question. They're not limited to components either. This particular code file that we're in right now is not component code. It's a library that we're developing. And so this library is providing an example of the kinds of things that we would write with it. It just takes arbitrary string. So I've chosen this arbitrary string. So long, and thanks for all the fish.
Missed.
Oh my dear goodness.
You gotta get right.
See the power of the ensemble. Catching that before it went to full quest. Okay, great. So now we have an example of what we're gonna write. That's great. So then we would need an example writer. So we can have a control that is a behavioral class. This is just data. This is behavior, and behavioral class, of course, is redundant because classes are, or objects are first and foremost behaviors. Let me say all of this as if I came to that conclusion independently. I didn't. This is something that I've learned a great deal about from having been involved in the Eventide community. So thank you, Eventide community. And everybody else.
We didn't come to those. We didn't come to those conclusions ourselves either.
The folks that came before us all
Mhm.
conclusions. So we need to know what this example of a writer looks like. And so let me just get in here real quick. Can't get my right control. So here's an example of me putting code in the wrong file real quick. That was, wait a second. No, that was the right file. It's this file.
Get one all the way on the right. It's the right. Oh no, that's the.
Yeah, that's the one we're gonna
So
fill
that's
out.
under
I'm
control.
genuinely confused here. I'm sorry, this is where it gets rough. This is not supposed to be here, so I'm just going to delete that and pretend it never was there. So yeah, wait, show it to me. I'll have to edit that out in post-prod, of course. I won't, but so the convention, the notion of controls is one thing. It is expressed in Eventide as files that contain modules within a folder called controls, where you have the project's enclosing namespace and then a module controls and then a module naming the control that has a self.example at the bare minimum. This is where it's just like, here's a typical this thing. Some of the controls as you look through Eventide code will have different specializations of the thing. So like the account component, here's an account that has been opened. Here's an account that has received a deposit, and so on and so forth. We're not going to get specialized with our examples here tonight. This writer thing that we're building, it writes to a particular file. And so to do that, we'll need a file name example. Within the module controls, we need one called file names. Let me open that real quick. And I didn't erase that one. So here's an example file name. There is a temp folder in the repository, and here is an example file name for it. So I'm just going to go ahead and close that. This controls example is to return to us a functional if inert. No, this one wouldn't be inert, but just a writer is what it's supposed to do. So where does this example come from? Well, we're going to define that right here. This class is not yet a writer, but if we include the module that we are about in the process of writing, we'll get that. And this, I hope I will remember to explain later why line 13 is there, but I think it would just get us off track to bring it up right now. But virtual methods, object-oriented programming, if you've done it, you probably have encountered abstract and virtual methods. This is just a essentially a no-op virtual implementation for a method called configure, whose purpose we haven't covered yet. So that's what's going on there. Neat. So now we have a writer. If we were doing this TDD, we would now go fill this out as much as it is on the left, but we already have it, so we're good. So continuing on here, now we get into stuff more related to telemetry. We're going to declare something called a sync. And let's see, register telemetry sync, because I am completely ripping off the basic structure of messaging right, but with what I hope is a simpler example to let us focus on how the pieces fit together. This method, you will notice, does not exist over here, so we need to add it. And I am not going to attempt to do that for memory, so let me pull up the completed version of this. So again, if you want to cheat and look ahead, you could just go to the repo and look at it. So we need to have a method here. Register I guess I can just auto-complete that. Pass a writer. For those less familiar with Ruby, by declaring this method with self dot, that becomes a method directly on the module itself, as opposed to a method on instances that include the module. So notice when I call it right here, I have the capital W right dot. That tells you that I'm looking for a method that has a self dot in front of it, or there's a few other syntactical ways you can achieve this result. That's why this says self dot. You don't need an instance. That's not strictly correct, because modules are themselves instances of type module. It's a module method directly on the module, not a method on something that has included the module and been instantiated. It's kind of like a static method, kind of, but not really. I don't know if that helps at all, but anyway, all right. So what is the notion of the telemetry sync? So we saw in messaging, right? It uses telemetry and records some signals, but they're not going anywhere. It's just, it would be like writing messages to a stream that has no consumers in a way. Nothing, it's the pub without the sub. So the sync gives us a sub in it. And so the way we do it is, we're going to do this tonight because you don't have to follow this exact thing. We're going to do this line sync equals telemetry.sync. That will fail because we don't have that telemetry right there, doesn't exist yet. So as a sibling to this method, we're going to make a sub module called telemetry, into which we will put things related to our telemetry. And as part of that, it will have a module method called self.sync, where we will instantiate a class called sync, which doesn't exist yet, so let's write it. And we are going to include a module from the telemetry gem called telemetry sync. So this is going to give you some methods out of the gate that are helpful. One of them is this record method, where you can declare the kind of signals that this sync is interested in. So what we've typed so far, this class sync is saying, hey, I want to be notified whenever a written signal is given. Right, so it's kind of like when you start a consumer and say, I'm interested in the account command category. So the machinery of Eventide will dispatch to that consumer, or that consumer will pick up messages in the account command category that it will then dispatch to handlers. There's kind of an analog here. We're saying we are interested in written signals. So that's the thing that does the observing. The way then we actually connect it to the thing producing the signals is that writer that we got passed in. We are assuming it has a telemetry object in it, onto which we are going to register the sync that we just created, instantiated. And then we'll return that consumer so that we have a reference to it to use in our test. So what we said was, we have an instance of the writer, and we're passing that instance of the writer into register telemetry sync. It is going to instantiate an observer of written signals. It is going to then register that observer with the producer of those signals that is on that writer, and then hand us back a reference to the observer that it instantiated. And this is totally where visuals would help a lot. So any questions on that part? There's a thing producing messages, and we made a thing to observe those and associated them with one another. Okay. You may have questions about that later as we start to use it, and that's fine if you do. At present, this is the module that is supposed to have that producer of things, and you'll notice it's not on there. So we need to add that. This is the deepest into the specifics of Ruby we're going to get. So follow me on this one. If you're not familiar with Ruby, or if you are and want the refresher, when you notice right here on line 12, we are including some module onto this class. When you include a module onto a class in Ruby, if the module being included has a self.included method on it, notice it's on the module itself, so it's a self dot. Ruby will call it passing the thing onto which you're including the module. So if we made some class named foo and included text right, Ruby is going to call our module at this method and pass to us the class foo that's including it. Classes can be passed around in Ruby because they themselves are just instances of type class. So first class classes, kind of like first class functions in languages that have first class functions. So we have already included this on something. If we come back to this control here, remember we made this class example and we included text right onto it. When, oh, I don't even know what that did. Yeah, when Ruby executes this line right here, 11, in our control class here, it is then going to call this self.included, and this CLS right here is going to refer to this class definition. So what we're going to do with that is add some things to the class. So we can do class.classExec. This method comes from Ruby. Whatever we put in this block, it's as if we were typing it. Let me pull up that one we were just looking at. It's as if we had typed it directly here in the class definition. So
Because classes are objects and you can modify objects anytime.
So any changes that we make here to class definition, any instances that we later instantiate of that class is going to pick up this stuff as well. So,
is class exec like a constructor for the class?
I wouldn't say a constructor, more so a way to modify the class definition itself.
It's more like an eval.
Eval in the classes.
Well, actually, there's also a class eval, so that might be confusing. But it's just like it's as if you had written code in the original class definition.
So we're going to include another module here called dependency that comes from Eventide's dependency gem. By putting that within this class exec here, it is the same as if we had directly included that here in our example class that includes text right. But this lets us reuse this inclusion of dependency here. And so we need to do that so that, and then, sorry, let me type this line and then talk about what it is. This is the deepest we're going to get with Ruby here. From this point on, it's going to be usage of these things and not deep Ruby metaprogramming. This probably isn't even deep Ruby metaprogramming, but it is jarring if you're not used to it. This dependency gem here provides us access to a method called dependency, to which we pass a symbol. And I think it was the very second session of this meetup we went through in detail what this is doing, where we talked about the doctrine of useful objects. It's on the YouTube channel. That has been like the most watched one of these replays we've ever posted. Serious numbers, like 50 watches of that one. So you know that's banging content right there. Basically, this lets us have dependencies that it's dependency injection but in a sane way. Imagine if dependency injection didn't have complicated dependency injection containers and frameworks, and it just worked in the operational context, but when you needed more visibility into what was going on, you could get it. That's what this one pulls off. So we're saying we are going to have a dependency whose name is telemetry. So when we have an instance of this thing, we can say that thing dot telemetry to reference this dependency. And furthermore, we are saying it is going to conform to the interface of whatever we pass here. The dot dot, that says go to the root of the namespace because we have a submodule called telemetry. We don't want to reference this. We want the Eventide telemetry gem. So that's why we do the dot dot here.
Is there a reason the telemetry module that we created named telemetry?
We could name it something else, but since it deals with the telemetry of this module, when it's fully out in namespace, you would reference it as text, right? Telemetry. And so it would be obvious like, oh, this is handling the telemetry concern for this module. So it's a sensible name. It's just when you'll sometimes have collisions like that where something at the root is named the same as a submodule. And so in those instances, they're rare enough that just do the double colon to get back to the root namespace. I think it's a good name because that is what it's handling, is the telemetry for this module. Just happens to have the same name as the gem. So what that gives us is, where are we? So this writer.telemetry call here will now not fail because by adding that dependency up there, we now have this member on the writer. So now anything that includes our write module that we're building here will now have a telemetry object on it to be able to record signals.
Does it get the .register method already, or do you have to
Yes.
configure it? Oh,
You know, that, good question, we'll get there.
okay.
Yeah, that is a method on the telemetry class. But to the astute observer who is familiar with dependency, let me say that briefly. So when you merely instantiate an object that uses this dependency macro, instantiate meaning you call new on it, the idea is that you should never have a null reference exception from one of your collaborators. If you instantiate it, you should never get a null reference exception. It should be able to handle that without crashing. Now that doesn't mean that your collaborator is going to actually do anything. And so what dependency does is by default, it will create it uses the Eventide mimic gem to produce an object that follows the null object pattern. I don't know if you don't know that one from object-oriented programming, a null object, don't confuse it with the value null that a lot of languages have, but a null object is whatever method you call on it, it will just return nil. So it won't crash, it just returns nil. When you pass a particular class as the second parameter to the dependency, the mimic object that gets created returns nil for any method that this thing has on it, but will give you a no method error if you call something that wasn't a method. So it's like you're using this as an interface and then it mimics the interface of that class. So to your question, when we instantiate something that includes this, it has a null object. It has a mimic telemetry. It doesn't yet have a functioning one. We will add a configure method later to do that.
Got it. Thank you.
And what I just said to him will make more sense in just a bit. All right, so continuing on then. So we've got our text that we're going to write. We have our writer object. The telemetry sync is registered now. So the signal that we're going to collect has an observer. We would then actuate the class that we're testing. And like, I'm seriously leaning heavily into the writer thing. I'm going to do two things here that might not make sense, but they will. Okay. In Ruby, if you ever see something that's like some instance dot and then parentheses, that's saying that this instance has a method named call on it. And that's the method that we're calling. So these two lines are equivalent. This is just shorthand for it. And so in the whole like FP versus OOP debate, when you do FP the right way, I'm sorry, when you do OOP the right way and your objects are behaviors, it's like, what's the difference? Scott, you were the one who introduced me to saying it this way, but how do you want to form your closures? That's the difference between FP and OOP. And so even invoking an object's principal reason for existing looks almost exactly like just like you're calling a function. So that's what that syntax means. In the messaging write class, there is a call method. So in your handler where you're like write dot and then the message in the stream in, you could call write dot call. I'm sorry. Yes, that is what we're calling. Point is, it gets aliased to write. All this is saying is we can also call this method, right? Notice there's no comma here. This isn't a function call itself. This is a Ruby keyword where you can give a method a different name. So if you had an instance of this thing and you called .call or you called .write, you're calling the same code.
If there's already the shortcut with, you just do dot parentheses instead of dot call, what's the point of aliasing it to something else? If there's already a shortcut.
I don't know, Scott, you would have to speak to that one, why the choice to alias it. My guess, I could take a guess at it, but if you could speak to that, that would be great. I don't know how to answer that one.
Is this in the controls, right?
No, it's in messaging, right? Let me go there real quick. Let's see. Messaging, right. The call method on messaging, right, is aliased to right.
Oh, you're asking me about my own code.
Yeah.
That was there to hedge the bets for the dominant mindset of the Ruby community at the time.
Okay.
Where you would see some folks wanting to use, instantiate the writer and call writer.write, which is redundant and superfluous and unnecessary. So really it's just it's an accommodation for social psychology more than anything to do with the necessities of software design. If we didn't have to deal with sort of the issues of mindset in Ruby community, we would delete line 81 and then not even deal with it.
Okay. Well, then in that case, we'll just delete the equivalent in the code that we're
Right.
doing. Because yeah, that is writer.write. What else is a writer going to do?
Yeah. And that's why we call it write. Like that's when you instantiate the dependency for the writer, it's the name is usually right. Actually, the class in Eventide is write.
Yeah.
And that really, we did that to force the issue that classes are behavioral. Every developer comes up through ORM, but it's kind of like if you don't leave that, it's kind of like never taking the training wheels off. And it's kind of like imagine the Tour de France where everybody ran $10,000 bicycles, but all of them had training wheels. That's kind of like I think how you can think of as software development where people never actually graduated from the from the first levels where ORM is. ORM teaches you that objects are rows in the database. I mean, objects have to be rows in the database if you're encapsulating the data of a row in a database or an object, but that's absolutely not what object technology is intended for. That's what the exception to the rule has to be when we're making data objects out of database rows. But beyond that, the other 99% of OO is behavioral, and that's ultimately what we reinforce and emphasize by just naming those objects in the imperative sense. Plus, it drives Rails developers absolutely mad, and we get a sick sort of pleasure out of that.
Nice. Okay, so with our call method defined, this test should run moment of truth, test automated. Let's see, we're in automated slash text write telemetry write. There's always something, isn't it? There is no uninitialized. Oh, right, we haven't initialized that constant yet. So here's what we're gonna do. For wait, why did
Is
Oh,
it
that's-
just not, is it not mentioned in the, is it not loaded in the loader file?
it is, this is from the component that uses all this stuff at the very end.
Oh.
So I'm going to just click for the time being. We'll get there. Okay, now it's something else. It's always something else. Virtual, right.
That's still, virtual's not included.
Yeah. That needs to be included right here. If I'm sticking to my example code, it's in that order. Ignore this. Oh, now what's the problem? No method build for text controls, right, example class, right. Yes, why was it trying to build it? Where did I say build? Sorry, this is where it's not polished. Inner control.
It looked like it was calling build from a control. Like this, unless I misread the stack trace.
No, you're correct. You're correct. The control does a build, but the thing that we're including, which is where the build is supposed to be, isn't there yet. So I'm just going to type, sorry, there's one more bit of Ruby here. I mean, the whole thing's Ruby, right? But this is Ruby.
It's been JavaScript the whole time. Oh
no. So I just need to type this and then we can talk through what it's doing. I'm going to leave it at that for now. Okay, so another submodule called build. When you include a module onto a class, instances of that class get the module methods. When you extend a module onto a class, the class itself gets the method. So the things that a module that you extend onto a class, that class gets those modules methods as class methods, not as instance methods. So that's the difference there. So we needed a class method called build, where we actually construct an object versus merely instantiating it. And so we put that into this module build so that we can extend it onto whatever includes this text write module. That isn't essential to what we're doing, it's just how the code works, but that just lets us be able to build instances of this thing, construct them. The new method is how you initialize something. Tap lets you pass a block that receives the new instance, and then you can make modifications, do whatever you want with that instance. And the return value from tap is the object itself. So we're instantiating it, getting access to this block, which is empty. So you're probably saying, why didn't you just type new? We are going to fill this out with more later, but it gives us a way to construct the object. So initialization is just reserve the memory, get an instance. Construction is, this is a fully operational instance of the object. And this is convenience, so that you as the user don't have to be like new and remember how to set up an operational one. We wrap that up in this constructor because it's nice to be able to have. So that, I think it should all run now. Oh, right, because I changed something. There we go. So we're passing now. Neat. So we have actuated it, but now we need to make sure that we're actually getting our telemetry. So it records the written telemetry, written being the signal that we want. So we're going to say, hey, assert, remember that sync reference that we have? Has anyone recorded any written signals on you? So this method, recorded written, when you include telemetry sync and you say, I want to record written signals, it is going to give you a method on that sync called recorded underscore the signal you want to record with a question mark, which in Ruby, your method names can have question marks in them. The convention is if it ends in a question mark, it returns a Boolean, not truthy or falsy, but literally true or false. And so basically what we're saying is like, hey, telemetry sync, has a written signal been recorded on you? So we want to verify that we're hooking up the telemetry correctly. We'll get an assertion failure if we, did that make sense? Like where recorded written came from? If we had called this over here, record, sorry, Bob, then we could have said, has a Bob signal been recorded? If Bob were in this call, he would be recorded because we're recording this call. I appreciate that. Thank you. So we are saying that we want this thing under test to record written signals. So we're exercising it and then saying, hey, was this signal actually recorded? Because if it's not, then our telemetry is useless. We're not getting the thing that we actually want. It currently isn't. So if we run it, we'll get an assertion failure on line 15, which is what this is telling us. Line 15, assertion failed. So we would need to modify our call method to make sure that it records that telemetry. If you had to guess the method name that you would call on the telemetry object to record the signal, what do you suppose that would be?
Bob.
I was thinking the same thing, I just didn't want to say it.
Exactly. Telemetry. This is the instance of the telemetry class, not the telemetry sync. So this is where the signal is published, written, signaled, whatever, however you want to say it. There's a record method on there to which we pass a symbol for the signal that we want to record. And then we can pass any data that we want. And in our case, we're just going to pass what the text was. I want to jump over to the messaging write module real quick. You'll notice that messaging write sends in this data structure, which is defined down in the telemetry module. Let me scroll down there just real quick. Where are you? Right down here. We define this data struct here. A struct, if you've done C, you know what a struct is. Same concept. This one captures a more complicated data with it, datum with its signal, because it's grabbing the message that you wrote, the stream name you wrote it to, the expected version you wrote it with, and the reply stream name if you put one into the message. So if you are recording telemetry and the data associated with your signal is complex, you can make a data structure to record it. That is not the case in ours. This is where what we're building here is simpler. We just record the text that was recorded with it. Okay. Now you may be tempted to think that if we run it now, the test will pass. This gets into the point that Brian made. We'll still get the assertion failure right now. Because the telemetry dependency on our write is still the mimic object. It isn't yet an operational telemetry instance. And the way that we do that is we come to the build here, and we're going to reference the telemetry gem class itself. It has a module method on it called, or I guess a class method on it called configure. And then we're going to pass that instance that we made. This we cover in that other meetup, but it's when you use a collaborator, it needs to get set up into whatever state it needs to be to work. And this adopts the posture that your collaborator should know how to set itself up. You shouldn't have to know all the details of how your collaborator object configures itself and gets ready. You just say, hey, telemetry class, I want you to prepare an operational instance of yourself. And then here's a reference to me. When you've got that, just assign it back to me. And in doing that, which is usually a controversial point that leads to really good discussion, but for tonight, that's not our focus. We are just going to accept that as a good idea. And if you would like to know more about it, you can catch me most Monday through Friday, 12 p.m. 1 p.m. on Twitch and come ask me about it. Or you can get me in the Omni Slack if you're interested. So that's just basically saying now our telemetry, we don't want a mimic object anymore. We want an actual telemetry object, like a bona fide operational, this one works in the wild telemetry object that will actually record signals for us. So with that in place, assuming I saved the file, looks like I did. If we run this, I expect the test to pass now. Okay. Who's lost in the chain of events that happened there? Or does anyone not understand the impact of this test passing? If you don't, I guarantee there's someone else in this room that does too. So this is a no shame if you want to revisit the flow that led to this test passing.
I will in the recording.
Yeah, I have a question.
Yeah.
I saw that when you had the record method on the telemetry thing, it was record and then you passed written as a as a symbol to it, right? But over on the right where you've got sync.recorded written, where is that recorded written method come from? Maybe I missed something. Maybe I.
No, that is a good question. That is one that the sync itself is this class right down here. And we included telemetry sync on it. See, Steve.
Yeah.
No, I totally understand. Thanks for coming. We include the telemetry sync module onto this class, which gives us access to this record method to which we pass the same symbol. And then if I jump back to, I say back because I think I have been on this page prior. When you include the sync on something, notice here in the documentation that it will add to your class a method called recorded underscore the signal in question with a question mark.
Yeah, sure.
So it's coming from the telemetry sync module.
Yeah. So I thought it might be doing that as a educated guess. I guess my next question would be, it's kind of interesting that it dynamically defines that method for asking if recorded written is there, but it hasn't dynamically defined a method on line 23 on the left there for the record, right?
You mean something like
record written and then pass it text as an argument?
yeah. No. Scott, tell me if I answered this one wrong, but the naming the signal that we're interested in, we do that on the sync. Whereas this thing right here is the telemetry instance itself. So this one is the publisher.
Oh, right. Yeah. Gotcha. Yeah. Okay. I see.
So here we could put anything, any type of a signal on here. But this is where we declare the ones that this observer is interested in getting.
Yeah, no, I understand. I confused the. I didn't realize I confused the sync and the telemetry objects. Yeah, okay, I understand.
It's a good question though. I would wager you're not the only person, because when I was learning this the first time too, I also would confuse those two and didn't quite see the boundaries between them. So that's a good question.
Yeah, the telemetry is an implementation of the classic observer pattern, observable pattern. And at the time it was written, that's what was on my mind, and especially the observable or observer. I can't remember what it's called, but the Ruby standard library has one that to me was just too missed the mark by too wide a field. But that in that observable pattern or observer pattern, there are multiple, there's a list of observers that get registered that have those signals forwarded onto them. And that's very much, in the spirit of PubSub. And that's definitely what was on my mind. But it's also like in the back of our minds now, whether or not to radically simplify this, next time around, because I don't think anybody has ever registered more than one telemetry sync at a time. And it just adds a layer of indirection that results in Sam's question again and again and again. And it probably can be pretty severely simplified. Also, we were going to merge, we didn't know how we were going to do it, but the grand design was that the logger and that the logger library, the telemetry library would be one would be made of the other. We didn't know which one would be which, and then everything would be everything would be telemetry. Obviously, even MessageDB is telemetry, but we ended up with that being kind of like, it's like the fever dream of a mad abstractionist looking to crack the code of the grand unified abstraction. It's just too many different concerns going in too many different directions. It's the engineer's disease trying to find the true abstraction. So there's a good chance that this can be simplified, and that may be simplified in the future so that all this isn't necessary. I would say this: it's the correct implementation of the kind of thing that this is, but I'm not exactly sure that correctness is helpful.
Right on. Thank you. Kyle, you had a question?
So the question mark, so the recorded underscore written question mark, that's saying, am I recorded or not?
Yes.
So if you remove it, would the assert just assert some, like whatever the value is?
I think it would give a no method error. Because the method name here, like you can define a method that's like, let's do a different thing. Like you'd actually define the method with the question mark as part of the name. And so if you then delete that, you're calling a different method that may or may not exist on the object. It would be the same as if like you left off the N. The question mark is part of the method name. It's neat in Ruby, but when you first encounter it, it's like, wait, how can a method name have a question mark on it? I grew up, my programming languages were C-based ones. And so it's like, this is strange. You can also have exclamation points in method names, but we're not going to get into that because that's a rabbit hole and I'm prone to going down those. So, so what we have verified is that we are recording this written signal with the correct data associated with it, which is great. But now we're going to use it to deliver on the promise of what this whole meetup session is about. But what we've done is we've instrumented the code. The code is now, as a first class part of the design of the code, making its what we need to know about its operation observable to the outside world, which means we don't now have to replace it with mock objects or anything. Like it is observable. It's the window in the pizza oven, right? For the most part, you just put pizza in, pizza comes out. There are times where you need to open that oven and look at how it's progressing, kind of a thing. We don't use it to get like the internal state of the object. This gives us a window into the operation that it's performing. We don't care about the internal state of the object. If we do, we have the wrong boundaries. But we do care about the operation that it's doing, and we have now made that observable to the outside world. So there are lots of great uses for that. One of them is in testing. So let us turn our attention to that. So we can now turn to the substitute. There is another interesting thing with the dependency library here. So when you call dependency, you give it a symbol, and then you pass it an object that works as its interface, it by default creates a mimic object that conforms to that interface, unless you do one other thing on top of that. And that is provide a constant named substitute. So it's not actually here where we're going to make use of this. Trying to think, where do we go next? Let's go to the substitute test. I'm going to close that file because I don't know how to open a file and have it appear on the right hand side. Let's see. So test substitute, here we go. and then I will reopen a different file. Here we go. All right, so if you have, sorry, let me just pull up. Okay, definitely, this all makes sense. I may be mad, but it's not because of this.
Mad isn't angry or mad isn't crazy.
Crazy.
It's crazy bad.
All right, so similar thing, we're gonna start it out. Let's get, we need an example of a file name. No, we don't need that anymore because of something I fixed and didn't update it in this code. We are now going to make a substitute instance. Controls are always where you don't want them to be. Always, every time. And this shouldn't say writer because we don't have to deal with the psychological deficits of the world at large here tonight. Write substitute is a different module that we don't currently have defined, so let's define it. Substitute, like so, and I just.
Those look like you're passing a file name into it.
Does, thank you. It was not. It was intentional until not worth the time to discuss. Let me get. Here we go. All right. So if you have this constant substitute on here, and you have a self.build, when this thing is passed in as the second parameter to a dependency call, it will call build on the substitute module. So I'm going to reference a class that does not exist yet, but we will write it in just a second. Substitute nerd tree. Nerd tree is the thing that provides the file tree over on the left. Substitute writer. Think it like that for right now. Then we need to define this class, which is a child of the substitute here. And it is going to include the module that we've been working on. So it too is a text writer. We are going to give it an attribute accessor, which is a Ruby syntax for doing def sync and def sync equals, so getter setter. If it's real simple, that's a much nicer way to do that. We are going to give a different build here. So we're overwriting the one that we inherited, that we got when we included the module. So we're going to make a new instance of ourselves. And the reason we do this will become apparent later, so just bear with it for now, where we're going to repeat the configure passing in the instance. And then let's just leave it there for now.
Is this similar to why when you do a new handler object, the handle methods inside it still work and are not?
Yes. Okay. Yes, because the dependencies that the handler has, like on store and on write, those classes have declared a substitute. And so we are sort of, I don't want to say mimic, we are imitating, doing something that's like a really simplified version of the write substitute. It just deals with text, doesn't deal with replies, so that you can see how it all fits together, and we're able to use this when testing the component, because that's where we finish. We have a component that has this thing declared as a dependency on it, and then we're able to use that within the components tests, because that's what we care about. The component handler uses this dependency, and we want to make sure it's doing it right without having to mock the dependency. So that's what we're developing right now. But so the test we're writing is making sure that the substitute functions the way we expect it to. Good question. So let's see, where are we? Go back to the test, Ethan. This is the one here. So we got right. We need to exercise it. Okay, so now this is an instance of this class over here on the left. And the tests that we're going to write here are going to look very similar to what we did before, but we just need to make sure it works on the substitute itself. So we're going, what was that?
How do you do write dot text if there's no call?
Call method.
Good question. So we are including the text write module on there, which was that big old file we were doing before. And that one, if you remember, we have a call method there. And so by including this module up here onto this class, we pick up the call method on any instances of this class that we make. That's how the mixins work, the code reuse. So, all right. Close that real quick, come back here. So we would want to know, hey, writer, did anybody write anything to you?
We did call it write up above instead of writer.
I did, thank you. Thanks for catching that. Here, I still have it called writer. I had not dealt with
rights.
Yeah. This one is supposed to say rights. It doesn't exist yet, but suppose you wanted to ask this write instance here, do you have any rights on you? Like, has something written to you? You might call that rights. And then you might say, oh, that's going to be a list of times that I was written to. So if it's a list, it would have a length. And we would want to ask, did you have one? So now we are asking this substitute, has anyone written to you? The substitute is a stand-in for the actual writer class. It is a version of the writer class itself. So this isn't a telemetry object we're dealing with. If you had like something that charged a credit card gateway and you had a substitute, you would want to know, hey, were you charged? Did you receive a charge? So we're now asking our writer substitute, did anybody write to you? That method doesn't exist, so we could define that over here. This is the moment, or one of the moments. We put this writes method on here. We can take an optional block that would be the just. Now, if we're within this instance of the class, how would it know if anyone has written to it? What do these classes have on them?
I'm not saying. Sync.
Yeah. Remember all this stuff we did with the telemetry sync here? Well, we registered the telemetry sync. And we haven't put that code in here. So when we built one of these substitutes, we made a telemetry sync and we went back to the module that's under development and we registered a telemetry sync on it onto our instance of the substitute. And then we took that instance of the substitute and we have this adder accessor on it. We could assign that registered sync onto it. Well, we already verified that the module is recording the signals, right? And we've registered a sync for those signals onto the instance of our substitute. What could the substitute use to answer this question of what rights have been performed on you?
Word rights question mark.
Yeah.
Is it called record written?
It is. Well, not quite yet.
Didn't know what you're gonna. Oh, written. That's what it is. I can never remember.
Oh my goodness, what just happened? There we go. Okay. Kyle, I think you asked or Sam, one of you two asked the question, where did that like writer dot record written, whatever.
Record written question mark.
Yeah, this is another method that the sync has on it because we declared a record, or sorry, a record written on it, saying we're interested in signals called written. Another method that it will put on written records. Exactly.
Okay.
Yeah. So signal name underscore records gives you a list of all records associated with the written signal. So if we don't pass in a block, this has nothing to do with telemetry. This is just the way this method works. And it's the way that it works in the messaging write substitute as well. If you don't pass in a block, it's just going to give you back every time that the written signal was recorded. So if that length equals 1, then we recorded the data onto the substitute. Right, but however, we don't just want one instance there. We would also want to know that the correct data was written on there. So we can say, hey, sync.records. Guessing this is a method that tells me everything that was recorded on there. Instead of guessing, here's an array of any signal that the sync got. So array of all records. So we're just going to grab the first one of those, this .data. So the actual records that are recorded into the sync have a timestamp that they were recorded at and whatever you passed when you recorded the signal. So we're just getting out that data real quick, and then we're going to make sure that it matches. Assert that the data that we just extracted is equal to the text that.
Two recorded data contexts.
Do because I misread my code. This was supposed to say records written telemetry. Thank you, Justin. I was laughing at myself, not you.
Yeah.
So
Me too.
but we gotta. That's for the telemetry library. Enumerate the methods that are generated by the record macro. So yeah, if you go to this page here, you can see every method that's generated by having declared record written on there. Okay, so now if we run the test, I think it should pass. Okay, so neat. Now we have a substitute. So if we wanted to use this writer in some other class, and we declared this writer as a dependency of that class.
Did you write the right? Did you run the right test?
Yeah, I
don't see that last
test.
Yep, see, I didn't prove anything.
Why
did
did
I?
You proved your old code still worked.
Yeah. We didn't break our old code. Here we go. No method defined substitute right. Where is this? Oh, I know where that is. It's in the substitute. I left off an R like that right there.
Down below.
And down below. Oh my dear goodness. Undefined method sync at substitute recorded data. Oh, it's the test at line 16. Oh, right. Right. Yeah, sorry. Sync equals right registered. So because we're gonna make the sync ourselves so that we can have access to it in our test. We don't actually configure the substitute as part of our thing.
Yeah, writer instead of right.
Thank you, thank you.
I'm getting kind of tired, I'll be honest. I
appreciate you catching that. Where the right would have to go down here if we're going to capture the signal. Yeah, so no, it passes. Okay, so we made the sync. We made the writer. We registered a sync on it. So we sort of replicated calling build on there, and then we exercised. So we know the substitute is giving stuff. I think I'm going to skip the implementation of the file storage specialization. I think that's less relevant to what we're trying to accomplish tonight, but you can see it in the code and ask me questions if you want. I'm going to just skip ahead to the final bit of all of this working. Check that all out. Let's start MessageDB real quick. We're going to go to this component here real quick. It has a handler on it called commands. That module that we started out writing was this, where we have a specialization of it that writes to files versus writing to a socket versus writing to whatever. So it follows the same interface as our module, but contains code specific to writing to files. It knows how to configure itself. As part of its configuration, we have to give it a file name that it's going to write to. That's subject for a different day. But we have a handler declared in this handler for a do command. And when we handle it, we're going to extract a thing ID from that do command. It's do command because do is a keyword in Ruby, so you can't name a variable that. And then we are going to use our dependency to write a thing ID. And what we know is that that writer, this text file write includes text write. So that call method with recording the telemetry is part of this specialization here. The telemetry is getting recorded. Then we have a test for this handler down here in handle commands do. So we instantiate the handler, and if we just instantiate it, this is not an operational dependency. If this thing has a substitute module on it, we will call that thing's build. We just finished developing that substitute. So that substitute, we're going to have that substitute object here. We're going to get a controlled do command here. We're going to extract its ID. We are going to actuate the handler, and just like, this is the good stuff here. Notice how the handler, you can just instantiate it and call a method on it. Wouldn't it be neat if you could do that on your controllers in the predominant Ruby-based web framework? Can't do, but anyway, we're just going to deal with it being called writer for right now because that's how I wrote it before. Then we're going to say, hey, let's get a reference to that dependency. And then we want to say, hey, dependency, did we use you to try to write something? And so the ID is what we're actually writing. We're doing the block version here where it's not just was anything written for which this block evaluates to true. Did we write something with that particular text? And then we're going to make sure that we actually did that by refuting that text was nil. So if it didn't find one where this evaluates to true, this will come back as nil. And we want to refute that that thing is nil. So that should look, for anyone who's written a handler test, that should look a lot like the writer.oneMessage call combined with the writer.written call. Ruby test automated handle commands do write, and it works. So we're using the substitute, and then I don't even know if this is useful, but let me just run one thing here real quick. Test interactive write do command that will write one of these do messages. Here's message DB. You can see it's right there. Sorry, everybody. Table plus does not let you increase the font size by hitting command plus. I love the program. Otherwise, that is, and I don't know. I don't know why they did it that way. They did. So now if we were to start, first of all, let's make sure that the target file is empty. So test component is not empty. That's from the previous run. I'll just go ahead and delete that. And then we can run the component. And it's not script, it's script start. Component is running. Surely by now it has had time to do its thing. And there you can see it wrote a new identifier into there. Because this component doesn't write messages, it writes to this file, which is silly. You wouldn't do that in the real world, but so that completes the loop. Now then, the one last thing I want to then go into is the messaging write substitute. So as you're writing your components, you are going to use this substitute a lot because you need to verify that it's written the correct messages. That is not part of the Eventide code. It is not littered with extraneous puts calls there. That was me earlier. This shape should look familiar because I stole it or was inspired by it. This looks exactly the same here. So this class is for actually writing messages to MessageDB. It includes messaging write, which is our analog to that is the text write, the accessor sync. You can put this substitute into a state where the next write to it will raise an expected version error. That's very useful when doing handler tests. Out of scope to talk about why that is here today. Here is the call where it will raise that. super here defers to the actual write method in the module. We have the same hipster twaddle here. Sorry, Scott. But here is where's the one that we use a lot? One message. Let's come down here. This is the first one you'll probably encounter on the substitute, and I scroll right past it. Here we go. One message write. So this is a method that will give you an error if you wrote more than one thing that matches it. So you'll call often in your handler tests, hey writer, was one message written that matches the following condition? And it's usually a test like an event of the same type that you're trying to write. I think that could really use actually looking at an example. Sorry. If we go to test automated, handle commands, closed in the account component. After we run the account component or actuate it with a close command, we're trying to find out, did you get one instance of a messages events closed written to you? So we're calling the one message, which is this one right here, it's aliased. Let me go, aliased right there. So one message write is the same method here as one message. We pass it a block that will select for events that are instances of messages events closed. When we send a messages commands close, we expect to see a messages events closed when it is on the golden path. What do? Cool. Well, we receive a block. We're going to go to message writes, which is right up here, which we can pass a block to, and telemetry sync right here. Written records. We're going to map over them and extract all the messages from the data objects if the block is nil. If the block is not nil in our case, so instead of getting all of them, we're going to get the ones for which the pass block is true, and we're going to call the pass block with the message that was written, the stream name it was written with, the expected version it was written with, if it was written with one, and the reply stream name if it was written with one. And so back up in our test, we only care about the event itself. So when we call one message, we receive that block, and it is going to call message writes with our block. Message writes is going to skip this because we passed one. It's going to go to its sync and say, hey, go through all of your writes, your written signals that you got, and pick out of it the ones for which this call evaluates to true, and then map it and hand back the messages that matched it. Right? So it's basically, the way that it is able to provide this functionality is because messaging write was recording the telemetry of what it was doing. And then the substitute uses that telemetry to tell you, here is the event that was written, right? If that telemetry instrumentation wasn't there, we would have to come up with some unholy mock object to replace the writer on there. And I don't know if you've ever had the experience, but I've worked on code bases where you look at the test and you look at the code that ostensibly is under test, and this is so heavily mocked, it's not even the same code. You are now testing the mocks, and they pass just fine. And then you look at the two and you're like, these can't both pass at the same time, right? Don't test your mocks, test your actual code. And so by the write class itself being observable and putting that observability as a first class design concern into itself, it is now very simple to tap into it and ask it questions about what happened to it. And we don't have to construct that incorrectly as the testers because the developers assumed their proper responsibility to make the class observable to us. That is the coup de grace of it. We can go through more of what these are. Oh yeah.
So I guess like this makes a ton of sense when you control all the code, but if you're working with like an external API or something like that, are mocks then appropriate there, or
let me show you how we do that. So in the code that we did, we have this storage thing here, and if you look in here, this is where we are actually going to right. Nope, that is a test. Sorry, let's go to the actual storage code of here. Where is it? Storage. Store, here we go. So in this call, you can see this is where we actually wrote to the file. You could pretend that this class came from a third party. And so if we go to, we didn't actually write this because the night's dragging on too much. But here in our, no, not there. Here is the completed module here. I guess what I'm trying to say is what you can do is take third-party thing that you don't control,
Substitute.
wrap it in your own class.
Okay.
That class can then have a substitute.
Okay.
And so your operational one would then call this thing. But this one would then have the substitute to record the telemetry of how it was called.
Okay, I see now. Yeah, that's cool.
And then you can use.
There's also a fundamental law of mock objects in design with regards to mock objects that you are not supposed to create a mock of anything that you did not code. So the general answer is to, should I create a mock of a third-party API, is already answered in more fundamental, the more fundamental laws of design. The problem is knowing them or not knowing them, but it's a heck of a step down a dark path to start mocking things that aren't yours, or the colloquialism is don't mock things that don't belong to you.
Got it.
That doesn't solve the problem of testability. You're still sitting there with something that can't be proven. And Ethan's answer is absolutely right. You would create some use case specific command object that then uses the API rather than coupling to that third-party API library directly. Now, you could say that you can get a lot of speed points by not doing that, but that's like trying to fly cross country on an afterburner. On the afterburners, you'll burn all your fuel, half an hour into the flight, and you'll be done. You can go fast at the beginning, but you'll never be able to sustain pace at that by doing things like skipping over the right design things to do and trying to take shortcuts. It's just that most software projects take the shortcuts, and that's common norm now, and no one really not no one, but the vast majority of software projects have not experienced high performance in terms of high performance teams, high productivity teams. So it's kind of shocking to even try to talk about what a high performance team is, because explaining it is kind of like trying to convince people that superheroes exist, or that you can run this at faster than a speeding bullet. And it's a common thing, and it should be expected, because it's been so forgotten, I guess, in the last 10, 15 years, that if you study design, practice design, learn it, live it, you're going to go a hell of a lot faster, but over the long term, not over the first couple months. If you're, trying to score brownie points with your boss, then it's like anything else. Just forget about the safeties.
We believe in paying the costs and achieving the long-term speed up. It's huge. If we've ever done mocks, and I'm not saying whether we have or not.
Oh, I certainly, by the way, I certainly have. Like I used to teach workshops on it.
So, but now we know the pattern, and we're going to slow down and do it.
I like to describe mock objects this way. I could pick my nose with a jackhammer. There are more elegant ways to do it. Putting a mock object in a test script is like trying to, dig a garden with dynamite. It's an incredibly destructive like it's like putting explosives in your code. It's an incredibly destructive thing to do to your design. The design should already accommodate it. Oh, by the way, that doesn't work with Active Record. Active Record is a library. Most of Rails was kind of like a library. My joke today, actually, this has come up several times. Today's joke of the day is, I think Rails was an experiment to see how far a group of software developers could get in writing a framework while disregarding all the possible safety measures that they could. So you can't do it with Active Record because there's no writer. Like, why does this work in Eventide? Like, why would anybody go to that? Like, I hope somebody in the audience is thinking, why would anybody go to all this length? Like, look at all the hoops and all the indirections that Ethan is jumping through. Like, why would anybody do this? And the answer is, we did it once. We only had to do it once because we know what we're doing when it comes to design. We have one writer. In an Active Record based application that has 100, forget 100. Let's say it just has 20 Active Record classes, right? That's 20 writers. Not one writer, 20 writers. There's no standard interface for data access. You got 20 of them. To do this kind of thing with all of those, it would be absolutely the wrong thing to do. Now, we would also not introduce mocks. We would use another technique where we have any kind of thing that does data access, whether it's a read or a write. Our business logic, i.e. our controllers, or anything else would never interact directly with the Active Record classes. We use the Active Record classes only as data access classes. And then we have command objects nicely organized in a good taxonomy under the lib folder in a directory called model. And you do not touch the database without going through those classes. Those classes can then be instrumented, but we'd instrument them in a lot lighter way. Like we wouldn't use telemetry. We'd actually just use something a lot more basic. And the mimic library that Ethan was talking about actually has a means of doing some extremely rudimentary recording. And that's already at hand when we're building substitutes. So there's a whole bunch of other techniques to make this particular class of techniques a little bit more lightweight to use without going through all the shenanigans of building telemetry sinks and substitutes that use the telemetry sinks, except when you have a highly centralized, really super critical piece of the infrastructure. And you can imagine in Eventide, the writer is like one of a very small handfuls of classes that are extremely critical to every implementation, to everybody's code that they write. And therefore it's extremely necessary for us to create the most observable code that we can, so that we can prove that it works exactly as expected before we hand it over to anybody else as well. The interesting thing about the writer's telemetry, it can also be activated on a non-substitute writer, like on an operational or quote real writer. Yes, it works on the substitute, but the telemetry can also be turned on when doing production writes. That's so that we, the writers and maintainers of that library, can observe not only with our automated tests, but also with interactive tests. We can do things like just dump the telemetry to the terminal just to have a one last final check to certify that yes, we are absolutely certain that when we unleash this on the community, that we're not not destroying other people's businesses. So thank you.
So we're almost at time. We're going to wrap it up with just two things. One, Scott said a word that may not be familiar to everyone here in person. He said the word hell. That could just be heck. So you could. That's a joke. But as an example of controlling an API they don't have control over in the Eventide code itself, if you go to say message store Postgres into lib, sorry, that one, Postgres, put, for example, when you write, you go through this class. I guess session is the one that actually wraps the PG connector library. That's not something that Eventide created. So the interaction with PG itself is wrapped in another class called session, which is declared as a dependency. And so now you get all the same, you now have control over that.
You do the same thing if you're working in microservice architecture?
Oh, that's a longer question. So microservices, as it would be understood within the Eventide community, isn't going to be a collection of web APIs calling one another. So if we change that to say a web API, if you had, like, suppose you were doing something with Stripe and you wanted to, your code needed to call Stripe, you could write a class that has the Stripe library as a dependency. This class, you could then make a substitute for to make sure that you are calling it correctly from all your other code that's making it. So third-party APIs, the database, a video transcoder, any API in the more general sense of the term that you don't own, you would wrap it in your own class. Now I can control this thing, or classes, you said.
Right, yeah, you could have different, like if the API itself has multiple uses or various things that it does, you could have different command objects
That's a good point.
that then
Yeah.
do that aspect of the API and then control the, anyway, yeah.
The Stripe API probably has like 17 different useful methods on it. You would have a
Yeah.
class for one of those uses.
It's probably like stripe dot, and then everything you could do is a method,
Yeah.
right? That's very, very typical. It's the kind of, it's like a code style that really comes from, you know, how Rails is done in the Rails community, sort of imposed on the Ruby community. I mean, it's a good bet, right? Like everything, you know, 99% of things done in Ruby are going to be done with Rails. So if you build a library, making it like have the same aesthetics as Rails is probably a good safe bet for adoption. Let's say I would assert that the more correct way to do that is to create one class called charge, you know, stripe : charge, that does that one thing, and then delegates to the Stripe API. But because you control the stripe : charge implementation, you can instrument it any way you see fit. So here's probably something like in terms of like the long-term bet, like we're always talking about the long-term bet. We do things for long-term speed, not just short. Like we do things for the marathon, not the sprint. We don't try to do a cross-country flight on afterburners. So this might be a shocker to you guys, but just to show you, just to sort of elucidate like how far this bet can go and how profitable it can be when you really, really, really know what you're doing, when you know the ancient art of structural design and can leverage it to your advantage. It's not magic. It's literally the furthest thing from magic. It's the most unmagic thing there is. It's the only science in software or in software and application development that there really is. We don't use the systems we build, or the project that a few of us run, we don't use any third-party APIs that are shipped from a vendor or that we can find in the open source. We build every API for a third-party service we built that from scratch, because that amount of time it takes us to build is ultimately lesser or lower than the amount of time we would waste trying to deal with somebody else's uninstrumented API that would make our proof code, test code, make our provability that much more difficult and would slow the project down as we built more and more and more code that leveraged more and more and more of those APIs. So we bring those APIs under control all the way down to the HTTP calls, because it's just not that like, but we're talking about over the long-term life of a system. Like once we amortize those costs and we know what those cost curves are, we're confident that we can go faster than those curves suggest, then we know that the economics of it matter. It's hard to pull off when all of this stuff is really new and you're kind of taking guesses what the implementation patterns should be. We have the advantage of having done this numerous times to have the experience to do it and to teach it. So I'm not telling you guys this so that you go back to your bosses and say, you know, I learned at the Utah Microservices meeting that we should throw away the Stripe client and build it from scratch. That's guilt that I definitely don't want to walk around with. But there is a world, a parallel universe of software that's done with an enriched understanding of software design and structural design. We're doing just that is in fact a more cost-effective advantage than the alternative, especially when the clients that are provided and the API libraries that are provided are not designed for instrumentation.
Awesome. Thank you, Scott. Thank you, everyone, for coming. That was a long one and a bruiser. I appreciate so many being able to stay through that all. Thank you, Nadeem and LVT, for hosting us. Yeah, that's today's.
Thank you.
Ethan, you should do Mimic. I'm signing you up for even more work. I think you should consider doing a session on the Mimic library.
Yeah.
I think you can show the other side.